Hi guys, so today is just one of these optional kind of extension videos. It's going to build off of what last week's was. So last week we kind of looked at just the basics of what a series and a sequence was, finding partial sums, and just going through a lot of that vocab. What we're going to do today is we're going to look at a couple specific formulas to help us find sequences and help us find partial sums for a specific type of sequence. So that sequence that we're going to look at is an arithmetic sequence. And what makes these stand out from other sequences, let's look at examples A and B. And looking at examples A and B and seeing how those numbers change, you can probably figure it out. On A, I'm adding 3 each time. On B, I'm subtracting 2 each time. So what we refer that to is our common difference. Right? So there's a common difference. You're either adding or subtracting some number each time. So if we want to write that sequence, there is a formula that we can actually use to help us write it. So whenever we see sequences, a sub n is the nth term. Okay, so if you want to find the 7th term, then a sub 7 would be the 7th term. A sub n is basically just saying the nth term. That's the sequence rule. A is the first term in that sequence. D is that common difference, so what you're adding each time. And n is the term number in the sequence. So if you want to find the 3rd term, n is 3. So to write the sequence, this is going to be a sub n. So it's going to be the first term plus the common difference times n minus 1. Now, if you want to simplify this and FOIL and make this 3n minus 1, it still works. And actually, algebraically, this is probably what you'd be used to, because if you think about these points, let's say this is term 1, 2, 3, and 4. Well, if you were to write the equation of the line that has the points 1, 2, 2, 5, 3, 8, and 4, 11, that line would be 3x minus 1, because these are basically linear functions. All right, let's look at the next one. So I would do a sub n is equal to 7 minus 2, n minus 1. Again, if you want, you can rewrite that, make that negative 2n plus 9. So once we have that sequence, we can use it to determine certain things. So in this next one, we want to find the 105th term in the sequence. So let's start by finding the nth term. So a sub n is going to be the first term plus the common difference, which I'm adding 4 each time. Then if I want the 105th term, then I'm going to plug in 105 for n. Plug that in, that's going to be 4 times 104 plus 4, which is 420. All right, so what we're also going to look at are partial sums. So there's actually 2 different formulas that we can use for partial sums for arithmetic sequences. Now the second one is probably the one that makes the most sense logically, and we'll look at that second one first. So using this formula, if you think about what this is saying, okay, the sum of a set number of terms is equal to the number of terms times the first term plus the last term divided by 2. Well, think about first term plus last term divided by 2. That's basically giving you that middle value. You take that middle value, you multiply by the total number of terms. Since that middle, we're going to be constantly increasing by the same amount, multiply by how many numbers there are, that's going to give you that sum. This first formula is basically taking that second formula and replacing a sub n with your sequence formula. So a sub n for arithmetic sequence is, well, let me not write the a sub n again, that's going to be a plus d n minus 1. Well, if I replace that and I add those together, I get 2a plus d times n minus 1. It's divided by 2, and it's multiplied by n. So that gives me that first formula. So that's really where that comes from. So you can use either of these. I will tell you the first one has a few cases where it's a lot easier to use. It really just depends on the information you're given, though. All right, so looking at this first one, we want to find the sum of the first 30 odd numbers. So the notation for this is a capital S with a little 30. So the sum of 30 numbers, let's go ahead and use the first formula for this one. So I'm going to do n, well, I'm adding 30 numbers, 2 times a. Well, the first odd number is 1, the common difference of the odd numbers, 1, 3, 5, 7, etc. That common difference is 2. N again is 30. So then I'm doing 29 times 2 plus 2 divided by 2 times 30, which gives me 900. Now, if I wanted to use a second formula, I could, but I'm missing some information because I know that I'm adding 30 numbers, so I know this would be 30. I know the first term is 1. I don't know a sub n. I don't know the 30th term. So if I want to use the second formula, I need to find the 30th term using the sequence formula. So to find the 30th term, I would do 1 plus 2, 30 minus 1. So that's going to give me my 30th term, which is 59. Now that I know that, then I can find that sum using this other formula. So 30 times 1 plus 59 divided by 2. That gives you 30 times 30, which is again 900. All right, looking at example 4. So I can use either formula here. The problem is I don't know n. I don't know how many terms I'm actually adding here. I know my a value, my a is 4. I know my d is 3. I know that the last term is 76, but I don't know how many terms there are in this sequence. So I need to start by using the sequence formula to determine what number 76 is. So 76 is going to equal 4 plus 3 times n minus 1. And now I can solve for n. So subtract 4, divide by 3, add 1, and I figure out that 76 is the 25th term in that sequence. That means to find this sum, I'm adding 25 terms. So your choice on which formula, I'll go ahead and use the second one because it's a little bit faster in this case. So 4 plus 76 divided by 2 times 25 is going to give me 1,000. All right, then the last one. So we're going to go ahead and evaluate this with sigma notation. So we got a couple options here. What we probably don't want to do is list all those values and add them all up by hand like we did when we first introduced sigma. So what I'm going to do is use this partial sum formula to help me find this partial sum. So what I know here, it looks a little different, okay? It's not really in that a plus d n minus 1 form, but I can pretty easily determine what a and d are. Okay, a is the first term. If I plug in 1, 3 times 1 minus 2 is 1. My common difference here is 3. All right, think about it kind of like your slope. Or if you weren't sure, plug in 2 and see what that difference is. Okay, if I plugged in 2, I get 4, so I'm adding 3. So I also know that the number of terms I'm adding, there's 120 terms, because I'm starting at 1, I'm ending at 120. Well, at this point, I have enough information to use my partial sum equation. So the sum of 120 terms would be 120 divided by 2 times 2 times 1 plus d n minus 1. And that's going to give me a sum of 21,540. Now the other option I do want to show you guys, you can do sigma notation on a calculator. On your Casio you can do it, and on a TI you can do it. On a TI it's a little harder to find. You got to do alpha window, I believe, to see it. I can't remember off the top of my head which menu it is, but it's one of those kind of shortcut menus like where you find your log base and things like that. All right, so then what we can also do is on a Casio. So let me pull up a Casio and let you guys see what this looks like. All right, so from the Casio, what we can do from the main run matrix screen is we can select math, which is where we find a lot of these options. Okay, so we're going to start with F4 for math. Then after math, I don't see that option, so I'm going to do F6 so I can see some more options. And then you're going to see that sigma. So I'm going to go ahead and do F2 for sigma. And then really you just got to fill in the blanks. So we'll go ahead and type in our sequence. That was 3n. So I'm going to do alpha n minus 2. The bottom of the sigma, I'm starting at n equals 1. Top of the sigma, the last number is 120. press enter, and you got your value. So it is still important that you guys understand how sigma notation works, because while the calculator can really help you to find those exact values, the calculator is not necessarily helpful when you're trying to write something in sigma notation. Like let's say you have x to the 3n plus x to the 6n plus x to the 9n, and you have to write that sequence in sigma notation. Then it's important to understand kind of where it comes from and how we're writing it. But if you're just trying to evaluate a sum, then this can help you get that done a little bit easier. All right, so that is it for your extension video. There's some practice problems if you want to see just kind of some different examples of this, but we'll look at geometric sequences as that extension next week.